Welcome 7th graders to Chapter 12, Lesson 1. I can count outcomes by using a tree diagram or the fundamental counting principle. This is starting on page 632 of your textbook. So please follow along there. All right, some vocabulary for this chapter or this section in the chapter is below. So one word would be outcome. An outcome is any one of the possible results of an action. So something that could happen, like if you're playing a game, you could either win, lose, or tie. That would be the outcome of the game. An event or collection of is an outcome or an collection of outcomes. So like in the event of a win, in the event of a loss, in the event of a tie. So it's one of the outcomes or a collection of them. And the sample space is the set of all possible outcomes. So, you could win, lose, or tie. So that would be the options for possible outcomes. So using a tree diagram to organize a list, if you're given a menu option, say you're going to go to a banquet, you're given an appetizer, you have the choice of a soup or salad, a main dish, beef, chicken, or pasta, and then dessert, you can have cake or pie. So to find out what are the total different possible meal combinations that I could have, could I get a soup and then beef and then cake? That would be different than getting soup, beef, and pie. So all of the different possible outcomes for your menu options. So what you do is you start with your first thing. So you can make a category for, okay, I could either choose soup or I could choose salad. Those are my first two choices. Then you branch off from there. So if I got soup, I could get beef, chicken, or pasta. If I get salad, I could also get beef, chicken, or pasta. So each first choice lends you to another 3 choices per. So we're at 6 different combinations right now. Then you choose your dessert. If you got soup, beef, you could get cake or pie. If you got soup and chicken, you could get cake or pie. So for every appetizer option, main dish option, you again have 2 dessert options stemming from each one. So if that makes sense for you. So starting here, soup could get beef or cake, could get beef or pie, could get chicken, cake, chicken, pie, etc. And then so your outcomes are as follows. So I got soup, beef, and then cake, or I got soup, beef, and then pie, and so on and so forth. So this is going to be our possible outcome section. And what that means is that there were 12 different meal choices for the banquet. So any person could have had 12 different options. And so it seems like, well, that wasn't really that many choices, 2, 3, and 2, but it really worked out to be 12 different meal options for the banquet. So you can give this one a try. How about making a tree diagram for if you a dime and penny or toss, you can make a tree diagram and figure out how many different answers or different outcomes could you get. So what I would start with is, okay, if I toss my dime, go down a little bit. If I toss my dime, I could end up with heads. It's not going to work out. I could end up with heads. Or I could flip it. Since a coin only has 2 parts, I could flip it and I could end up with tails. So that's if I toss my dime. From there, if I toss my penny, bear with my handwriting, still trying some new things. If I toss my penny, if I did the dime first and I got heads, well, if I toss the penny then, I could end up with the penny being either heads or tails. Same thing, had I tossed tails the first time with the dime, I still could have ended up with my penny being heads or tails. So the different outcomes then, as you can see, are I could have had heads and then tails. See if I can write with this again. Could have had heads as an option. I could have had heads and then tails as an option. Then I could have gotten tails first and then heads. Or I could have tossed a tails on the dime and a tails on the penny. So it's a little bit messy, but what you notice is there's 1, 2, 3, 4 possible different um, outcomes. 4 outcomes. So the fundamental counting principle, this just helps you from not having to make a tree. Say there were a lot more choices than just 2, like heads and tails. You can also find the total number of outcomes by multiplying. This is called the fundamental counting principle. And the key concept here says that if M has M possible outcomes, the event N has N possible outcomes. Then event M followed by event N has M times N possible outcomes. Again, those variables just represent something that can be changed, a number we don't know right now. So essentially, multiply the number of outcomes for each event together to get the total number of possible outcomes. So thinking back to that appetizer spot, we had 2 options times 3 options times 2 options. Well, 2 times 3 is 6, times 2 again is 12, which is what we ended up with for our answer. So we'll try that looking at baseball. Use the information at the left to determine how many different infield teams are possible when one player is selected for each position. So for the 2007 MLB All-Star Game, 14 players were nominated for each position in the infield: first base, second base, shortstop, third base, and catcher. So we have 14 different things. So since there are 14 choices for each position, we can use the fundamental counting principle. So we did 14 times 14 times 14 times 14 times 14 because first base has 14 player options, second has 14 options, the shortstop has 14 options, the third base has 14 options, and the catcher has 14. So you multiply all of those together instead of making a tree that says first base and then so on and so forth. And so what that means is there are 537,824 possible infield teams. So that is a lot of different combinations for individuals. Trying again, a restaurant offers a choice of 3 types of pasta and 5 types of sauce. Also, each pasta entree comes with or without a meatball. So we can make how many different entrees are available. So what we can do instead, originally you may start with wanting to make a tree, and I started to do this on my notes, and then I realized it was getting kind of messy and out of hand. So what I realized was that I could say, okay, I know I'm looking at pasta, and there's 3 different choices for pasta, and I know that with each pasta there can be a sauce, and you have 5 different choices of sauce: marinara, alfredo, etc. And then meatball, you can either have one or not have one. So that's 2 choices. So it's either like a yes or a no. So what I can do then is 3 times 5 and 5, and then times by 2. This is messy. Well, 3 times 5 is 15. And then bringing that 2 down times 2 would be 30. So that means there's 30 different possible entrees available. You can get 3 different kinds of pasta with 5 different kinds of sauce, and you can get a meatball or not. So depending on which combinations you use, you could end up eating 30 different types of meals. A little bit easier than the tree. So another topic we're going to cover today is just talking about probability. Outcomes occur at random if each outcome is equally likely to occur. In this situation, the probability of an event is the ratio of the number of outcomes in that event to the total number of outcomes. So say, what were the options of me, getting bow tie noodles with marinara sauce with a meatball? That would be, one of the 30 options. So it's like the number of what you want to get, your favorable outcome, over the number of possible outcomes. So the total, kind of what you get when you do that fundamental counting principle. So looking below, if you're thinking about your class schedules, students at East Valley Middle School take 6 classes each day. They take math, science, social studies, English, Spanish, and music. What is the probability that Julio's first 3 classes are science, music, and math in that order? So we have to think, okay, first we know that there are 6 choices for the first one because all the 6 classes there. But if math or if science came first, that's one less choice for the second. He has 5 other classes to choose from, and then 4 classes for the next one. The reason the number goes down is because, well, you wouldn't have science twice in the day. So if you have science the first period, it's no longer an option for the second period. So you have to subtract one of the options away. So you do 6 times 5 for 30 times 4 for 120. So there are 120 possible outcomes. There's one way that Julio's classes can be science, music, and math if it's that specific order. It's a different order if we said science, math, then music. But there's only one order that it would be those 3 first. So what that means is if the probability that it goes science, music, and math in that order, this is how you represent what event you're trying to show, that is 1 out of 120. It's one of the possible orders. So this can also be written as a decimal if you divided 1 divided by 120, or as a percent if you multiply by 100, as 0.8%. So there's only 0.8% chance that he's going to have those 3 classes in that order. Checking your progress, if a number cube was rolled, what's the probability that the sum of the numbers is 12? We think you have 2 number cubes. That means there's, dice, which is 6-sided. So you would start with 6, right? 1, 2, he needs a 6 and a 6 on the other die. So that's really like a 1/6 chance and a 1/6 chance. So there's one chance that it's going to be, you're going to roll a 6 and then you roll a 6 on the other one because that's the only combination that gets to 12. Well, you have 6 rolls on the first die, 6 on the second. So that's really 1/36. Kind of messy. This next one's a little bit applicable. A lot of you put passwords on your devices. And so Kelly accidentally put a password on her iPod Nano and forgot what it was. It is a 4 digits, and the digits are 0 through 9. So, it could be your birthday. It could be, say your birthday was January 1st. You might do 0101 as your password, for example. So we're wondering, what is the probability that she will figure it out on her first try? Well, 0 through 9, if you count 0, that's actually 10 digits. So you think her passcode, maybe you want to draw a picture. So it's number 1, the second box on the iPod, the third box, and the fourth box. Well, she has the possibility of having digits 0 through 9 here, 0 through 9 here, 0 through 9 here, and 0 through 9 on the last one. It said nothing about it can't be repeating numbers or anything like that. Could be 1111 for all we know. But if she's going to do this on her first try, we have to think, well, how many different options are there for her to choose? Well, 0 through 9 is 10 digits. 0 through 9 is 10 digits. So she has a 10-digit option for every single digit in the 4-digit password. So we do 10 times 10 times 10 times 10 4 times, and we get 10,000. Well, there's only one password that's correct, so she has a 1 out of a 10,000 chance to end up with the right password on her very, very first try. So different things to keep in mind. Probability, number possible out of the total outcomes. Ask some questions on your paper. Come to class with things you're wondering or something you related this to and something you could use it in your life and situations. Rewatch, watch someone else's, check out the book, personal tutor. You know the drill.